Hello everyone, welcome back to Code to CloudX. So in this video we are going to cover everything step by step. So first we will understand how to run our Spring Boot applications using the java-jar command. Then we will create a Docker file and understand each instructions in detail. After that, we will build our Docker image, run it as a container, and finally we will push and pull the image using Docker Hub with a complete practical demo. So make sure you watch till the end because by the end of this video, you will be able to run your Spring Boot applications inside Docker like a pro. In my last video, we learned how to install Docker and understood the basic Docker concepts. We also saw what gets installed when we install Docker, especially the Docker client and Docker server components. So today we will move one step ahead and learn how to create a Docker image. So for this demo, I am using the same Spring Boot applications that I created in my earlier Spring Boot series. So you can check. So here in Spring Boot applications, I have just made a few small changes in that project. Earlier, some of the business logic was inside the user controller only. Now I have separated that logic into a proper service layer. If you will see, I have injected user service and its implementation classes. If you will see here, user service interface and its implementation classes. And I moved all the logic here only, user service implementation. And I also injected user repository into the service class. So now the code structure is cleaner and more aligned with real project standards. Before directly creating the Docker image, I want to first explain how we normally run Spring Boot applications and how the jar file is created because that will help us understand the Docker file much better. So first let's open the pom.xml file. If you will see the pom.xml file, so in the pom.xml file you can see we have artifact ID, we have version. So here packaging type is set to jar. This means Maven will generate a jar file for our Spring Boot applications. So the naming convention of your jar file will be combinations of your artifact ID, your version, and extension will be jar. So before building the project, I will delete all the existing .class files and old jar files from the target folder. So now my target folder is empty. After that, I will build the project using Maven command. So let's go to the project directory. Here, open git base here. So here I am not showing you how to install Maven, how to configure Maven, because I hope you know. So simply mvn clean install. So this command will clean the old build and generate a fresh build of the application. Which got successful, right? So our Maven clean install, if you will see the target folder, so here jar has been created. So if you will compare with pom.xml file, so this jar is a combination of these three property: artifact ID, version, and packaging jar. So now, once the build is successful, we can run the application in two ways, right? So first way is by using Maven Spring Boot run. What we will do, I will run through mvn spring boot colon run. Run the Spring Boot application directly by using Maven. So here it's getting start. I show you one thing. If you will come into the pom.xml and you will also find the build related configuration that helps in packaging and running the application properly. right? So my application got started, user service application. Now I test that applications. So I have configured my Spring Boot applications with SQLite DB. If you will see the application.property, I have configured with SQLite DB driver class name. I test. Okay, so here you can see I got the response which are available in my DB. Okay, make it Control C to close. Okay, so it's shutdown completed, right? I clear it now. So the second way is to run the application using the generated jar file with the command. So I'm using java -jar target and jar file name. I will copy this jar file name from here. So simply refactor, rename, and I will copy this one. Control A, Control C, cancel. That's all. And here it is. Okay. So why I am using this approach? Why I am showing you this approach? This approach is very important because when we create a Docker image inside the Docker file, we generally use the java-jar command to start the applications. And the biggest advantage is that this approach doesn't require Maven inside the Docker container. We only need Java and the jar file. That makes the Docker image lighter and more efficient. Okay, so let's try with this. Just start. Tomcat started on port 9091. Started application user service application. Now we can test it again through Postman get all user. Okay, so we got the response. So far, we have seen how to run our Spring Boot applications using Maven command and also by running the generated jar file with the java-jar command. Now the next step is to create a Docker image for these applications. So before that, we have to make sure Docker desktop is running on our local machine. So here you can see the Docker desktop running icon. If you will right click on that and click on go to dashboard, so also you can come. So once the Docker desktop is open, you should be able to see the containers and images available in your Docker environment. So if you are using Docker for the first time, the containers and images sections may appear empty. That is completely fine. It confirms that Docker is running successfully on your local machine. Now to create a Docker image for our Spring Boot application, the first thing we need is a Docker file. So go to the project folder, right click on that, new, and choose the option to create a new file. And here the file name must be Docker file. Docker Docker file without extension. Now inside the Docker file, we will write the instructions which will require to generate a Docker image for our Spring Boot applications. The first basic requirement is Java, right? So that means our Docker image depends on Java and that Java should be available. So to tell Docker about this dependency, we use the from instructions. From instructions. And the from instruction tells Docker that our image should be built on top of another existing image that is called the base image. So in this case, the base image will be Eclipse Temurin 21-JDK. Okay, so 21JDK is the tag or you can say version of this base image. Multiple versions of this base image for JDK 21 version. So it depends if you want to change either different JDK versions, so you can select as per your requirement. So currently I am using 21 in my application. That's why I am choosing 21 JDK version here. And it's before we were using OpenJDK rather than Eclipse Tamarind. We used to use OpenJDK, but OpenJDK is now deprecated. Earlier, many people used the OpenJDK image directly, but for newer projects, Eclipse Tamarind is now commonly recommended because the old OpenJDK official image has been deprecated. If you can also search for this image on Docker Hub. If you will go into the Docker Hub, explore, there you will find the official OpenJDK image. Search for Eclipse Tamarind, this one, okay? And here it's a base image, and here you can find the available tags. So different tags represents different Java version and variants. Let me also add a comment for clarity. So start with a base image containing the Java runtime. After that, need to add metadata about who maintains this Docker image. So for this previously we used the maintainer instructions, this one maintainer, but now that is deprecated. So instead of maintainer we will use label, label, and you can give maintainer equal to code to cloud X. So instead of writing maintainer, we will now use label to provide author or maintainer informations. So it's a metadata. Next, we need to copy our application jar. We need to copy our application jar into the Docker image. And for that, we use the copy instructions. Copy instructions. Okay. So what we have to do, copy, and our application jar already have inside a target folder. So target slash jar file name, refactor, rename, control A, control C, and control. So with this copy instruction, I am telling to Docker that take the jar file from a local project target folder and copy it into the Docker image. So you can copy the same Docker image name, or if you want, you can change the Docker image name, just like I keep it user service dot jar. So what does this mean? You understood? We are going to copy our jar file from a local machines to Docker image. Finally, we need to tell to Docker that what command should run when a container is created. So firstly your image will be created, and from this image you will create a container of that image. Okay, so what command should run when a container is created from this image? So for that we will use entry point instruction. So Docker recommends the JSON array form for entry point. Okay, so here we will write double quotes, common, double quotes, common, double quotes. So it will be Java hyphen jar and your image name. So now you can understand why earlier I showed you how to run Spring Boot applications using Maven command and also using Java hyphen jar. So inside the Docker container, we don't need Maven. We only need compiled jar file, and we run it using the Java-jar command. This is exactly the same command we are using inside the entry point instruction. So the final Docker file will look like this. Okay. Now the next step is to build a Docker image. So open your terminal inside the project folder. Open git bash here. So I am inside my root directory, current directory of my applications user service. So firstly, we have to make sure Docker is properly installed and running. We can run the command docker version. So this command shows two sections, client version and server version, right? So if both of these are displayed, it confirms that Docker is installed and Docker engine is running correctly on our local system. Now the next step is to build the Docker image. For that, we will run the docker build command. Docker build. So this tells Docker that we want to build a Docker image from a Docker file. After that, we will use pass -t. So -t flag stands for tag, and it allows us to give a name and version tag to our Docker image. After that, we will pass the Docker Hub username. So what is the Docker Hub username? Pankaj Thakur 104. In your case, you have to copy your username, Docker Hub username. Simply paste Docker Hub username slash image name. So simply you can give image name, user service, and tag name. So it will be your base image name, user service, and tag name or version name. So simply user info or anything. Okay, and at the end the command we have is dot. So the dot represents the current directory. So it tells to Docker that the Docker file is located in the current folder, or if your Docker file is inside any folder, so you have to give the proper path of that Docker file path. So now let me execute this command. Okay. So the first thing Docker does is download the base image specified in the Docker file. Okay, right? So Docker download this image from the remote repository, and after that copy the jar file, and this confirms that Docker image has been successfully created. So now to see all the images in our system, we can run the command docker images. So here you will see the repository name, tag name, image ID created, and size, image size. So among these image, you can see our images, what we have created just now. And this one is the image ID. So if we want to see more detailed information about this image, we can run docker inspect and image ID name. So you don't require to give the complete image ID. If you will pass partial name, it will also work. 156 ECA. Okay. So this command display the detailed information such as, so you can see the environment variables here: Java home, path, Java version. Okay, so you can see. So Java home is set to 21, JTK 21. You will see the entry point command Java -jar and image name. and the operating system is Linux. So Docker container are built on Linux concept such as namespace and controller groups, which provides isolation and resource control. Okay, and we can also explore this information using the Docker desktop. If you will come here, you can refresh if it's not showing, and you can, if you will open this image, click on that image, Docker desktop will display all the layers used to build this image. Okay, got it? So, and if you have to filter out, so you can write user info, so you can filter out of your image as well. So now we will see how to create and run a Docker container using the Docker run command. As of now, we already have user service, user microservices Docker image available in our local system. And we created this Docker image using the Docker build command. So here now Docker image has been created. So now we will see how to run a Docker container from Docker image. So like Docker build, we have a Docker run command, Docker run command to create and start a container from this Docker image. So you can think of this like a new operator in Java. So in Java, with the help of new operator, we can create multiple objects from the same class. Likewise, using Docker run command, we can create multiple containers from the same Docker image. So for that, we have to write Docker run hyphen p. Hyphen p is used for port mapping. So here actually we do port mapping between host port colon container port. As we discussed in our existing video, that Docker container runs in its own isolated network. Because of this, service running inside the container cannot be accessed directly from outside. So if we want to access our applications from our local system or from other system or other browser, we need to explicitly expose the container port using port mapping. So we use port mapping to expose the container's port to outside the world. Okay, so here what we have to do, here if you can see, for my applications I have mentioned 9091 port in my application. For my application port is 9091, so I have to map this port. So in place of host port I will use 9091, and for container port I will keep the same to avoid confusion. So here first port 9091, as I told you, represents the host machine port, and 9091 second one represents the container port where the application is running. This means any request coming to localhost 9091 will be forwarded to the running port. Finally, we specify the Docker image name. So Docker image name is, so with Docker image name, we have to give the complete name. So when I execute this command, we can see that, so now Tomcat is initialized with port 9091, what we passed. But here we are getting one exception, unable to obtain isolated JDBC connection. C tools SQLite user DB. Okay, means my SQLite user DB what we have configured in our application.properties file is JDBC SQLite C tools SQLite user DB. It means this DB file exists in our Windows path. If you will see, I have configured the database user.db, which is available in ctools SQLite user.db path. So the error is happening. So this error is happening because inside Docker container, our local path ctools SQLite / user.db path doesn't exist. So actually what's happening when our application running inside the container, it runs in its own file system. It's in own isolated environment, not our Windows file system, right? So when we run this command, Docker run, so Docker starts a Linux based container, and that container doesn't know anything about our Windows C drive, right? Unless we explicitly mount it. So here what we have to do, we have to mount our local path user DB. So we have to mount that folder when running container. So for that what we have to do, we have to firstly we have to make the changes in application.properties file. So rather than giving the Windows path, here what I have to do, I have to give the container. It means what we will do, this local folder ctools SQLite, we will link to a container folder. So slash data and user.db. So what we are doing here and why this is important, because this is a classic Docker concept. If you will learn in production environment, application runs inside the container, but data lives outside the container. For example, your database, logs, any configurations. So that will be outside the container. And for that, you have to either volume or mount. So we made the changes in application.properties file. So we have to rebuild the application. Maven clean install. Now build was successful. Now again I will create the image slash image name user service colon tag name. So user info and dot. Okay. So we can see docker.io Pankaj Thakur, it means that image has been created successfully. So we can check now. So this image has been created successfully. So now what we will do, we will run the container. We can use the Docker. So now again we will use the Docker run command to create and start a container from that Docker image. So for that we will use Docker run -p port mapping and 9091 host port number and 9091 for container port mapping. But here we will do one more thing. What we have to do, if we make any changes, if any DB related changes, what we are doing in our user.db file, that changes should reflect in our local DB. So for that, what we have to do, we have to mount. We have to mount our Windows folder, that is ctools / SQLite into container at / data. What I am going to convey is that in container, if any CRUD operations we are performing, all the changes will be inside the container only. But what I want, if your container gets deleted, but your data should not be lost, that data should be exist in your local DB as well. So for that, what we will do, we will use -v. It's a volume mapping. So what I have to do here, I have to do -v, and we have to give the / c tools and SQLite colon data. After that, image name. I copy this complete image and I paste it here. Okay. So Docker run -p, it's for port mapping, -v for volume mapping. So why I'm doing this? Because I want any changes happens inside that data. So that changes should reflect in our SQLite folder. Okay. So just press the enter. So our server user service application has started, and if you will see here in our container, they are referring JDBC SQLite data and that user.db. Now we check the flow through Postman. We test the flow. Now I will go to Postman and call one of the API. So firstly we get all users. So here we have 1, 2, 3, 4, and 5 records. Now let's check on DB. So you can see here we have 5 records. So let's what we want to see if we make any if we create any resource and username J, user password and email. And this record doesn't exist in our DB, right? So I click on send button. So one resource has been created. So now let's see in DB, it's reflecting or not. So we can see these changes are exist in our DB as well. So whatever changes we are doing inside the container that are reflecting into our local DB. So now it confirms that our Docker container is running successfully. If you can see that our when we run the container using this command, so when we run the container using this command, so here there is one small inconvenience. What is? So when we run the container using this command, these logs are directly attached to the terminal, and we cannot execute other commands in the same terminal. Getting? So what we can do, firstly we stop the container, we press Ctrl C, okay? And now I show you one better way to run containers. We can start containers in detached mode. For that, we use -d tag. So what we have to do? Docker run, and before -p, I will write -d. So -d stands for detached mode. So now when I execute this command, we can see that Docker returns a container ID, and this indicates that container has started successfully and running in the background. Okay, so let's see. Now our terminal is free and we can run other Docker commands as well. And here you can see you got the container ID. Okay. So now, for example, if we want to see all the running containers, so what we can use? We can use Docker PS. So right now we have one running containers, that is Pankaj Thakur 104. This one Java command java-jar 30 seconds ago, and this is the port mapping 9091 or it's a it's a container name. By default it's a random name, and if you will see the container ID, it will be the exact first few letters. And we can also verify the same inside Docker desktop. If you will come inside, refresh, so it's our Docker image. And if you will go inside the containers, so you can see the containers information. This one is running. If you want to show only show running containers, so you can click. So this is the running containers. And if I will click on stop, then our containers will be stopped. So we don't have any running containers. Same we can verify through docker ps command. So we didn't got any response. And if I want to see all the containers including stopped ones, so you can use docker ps -a. So you can get all the containers information including stopped containers. So this command will display all containers whether they are running or stopped. So now if I want to start one of these stopped containers, so how we can start? We can write docker start and container ID. So just like I have to start this container, to control, and you can paste. So docker ps, again you can check. So this container has started, and also you can check here, so it's showing, right? And if I have to stop any this container, so simply docker stop and container ID, paste. So we can see here, okay. And here if we want to inspect the containers in docker desktop, so if we want to start, we can start from here also, okay. And if we will click on the running containers, we can see several tabs available. So here you can see the logs, SQLite DB, and also you can inspect all the informations, environment, entry point, all these things, and bind mount. If you want to run any commands, if I will type pwd, so it's showing the root directory, okay. Running docker container files, so all the files we can see. So all the instructions, how it's behaving, all the CPU usage, memory usage, network input output, read write operations. So you can see all the matrices inside this. So these are the specs of running containers, you can check from here. Now let me show you something interesting. What we do, I will start a container again. I will start another container using the same image, but this time I will change the port number 9091 to 9092, because 9091 on the host machine is already in use, so we cannot reuse it. But inside the Docker, each container runs in its own isolated network. So both containers can run on port 9091. The only thing that must change is the host port. Only host port we have to make the changes. So let's enter or come into the containers. So you can see we have two running containers, 9091 and 9092. The host port is different, 9091, but container port is same, because both are started in its own isolated network. So we can check through docker ps, docker ps. So we have two running containers, right? And we can test both containers. Firstly, 9091s, I am getting the response. Here I am getting the response. If I will try to access through 9092 port, so from this port as well, I should get the response. Yeah. So through this port 9092, we are able to access. So what problem does Docker solve here? So here we have three major benefits of Docker. First one is scalability. Second one is portability and consistent deployment. Means what? We can easily scale the applications from one container to multiple containers. Portability, they do not need to install Java, Maven, Spring Boot. Everything is already packaged inside the Docker image only. And consistent deployment means what? The same Docker image can run on a developer laptop, on a virtual machines, on a cloud server, or inside the Kubernetes. So the command remains exactly the same. This makes deployment much simpler and more reliable. Now we have successfully generated our Docker images and they are available on our local system. But keeping Docker images only in local system doesn't make sense in real world applications. Because eventually these images need to be deployed into dev environment, QA environment, or production servers. Just like we push our source code to GitHub, similarly we need to push our Docker images to remote repository. So we have some popular Docker registries where we can push our Docker images. We have Docker Hub, we have AWS ECR, we have Google Container Registry GCR, we have Azure Container Registry, we have GitHub Container Registry, but here we are going to use Docker Hub. So to push a Docker images to Docker Hub, we can use Docker push and username. So in my case, username is Pankaj Thakur 104 and image name is user service, and after that I have to give the tag name, and tag name is user info. Click enter. Now we can verify pushed images in two ways. So firstly we can verify through Docker desktop. If you will go inside the Docker desktop, so you can see Pankaj Thakur 104 user service, it's my Docker Hub username, then image name and tag. Same we can check in our Docker repositories. Click on Hub repositories. So here you can see public means what? Anyone can pull and use them. Click on that and you can go inside the tags. If you want to download this image from Docker Hub, so what you have to do? You have to use this command docker pull. So copy this command and firstly what we will do? We will delete the existing Docker images. Delete forever. Delete the containers. Okay, firstly we have to delete the images from containers. Delete. Okay, now delete from image. Delete the images. Now we will, and let's see is there any images with user service. No. So now what we can do, we can pull this image from Docker Hub. So now let's see. Okay, so you can see now this image has pulled from Docker Hub. So this is how we push and pull Docker images using Docker Hub. I hope this made the concept simple for you. If you found this helpful, do like, share and subscribe to Code to CloudX. I will see you in the next video. Thank you.